Hi, everybody. Welcome to the second expert exchange webinar at GBA. The topic tonight is indoor air quality. I'm Kylie Jacques, senior editor at GBA, and I have the pleasure of introducing our guests tonight. After I do that, we'll have a short presentation from Allison Bales, who will sort of set the stage around the topic, introduce some key concepts, and then we'll have a conversation to follow. I reached out to a number of very smart people in the industry to gather some questions together that this set of panelists could answer specifically. So it should be sort of a free-rolling conversation that will touch on the topics that we promised to touch on, but with some depth coming from industry professionals who have some pretty thoughtful questions, and some of them are in the audience. So thank you for sending your questions and sharing your thoughts with me. It's appreciated. Also, audience questions, you can throw those in the Q&A box or the chat box, one or the other. That's helpful, and we'll field some of those towards the end. We run for about an hour, but we can be a little loose with that if things are rolling. So I'll start with introductions. Allison Bales is a speaker, writer, building science consultant, and founder of Energy Vanguard in Decatur, Georgia. He has a doctorate in physics and writes the Energy Vanguard blog, which he shares with us on GBA. He has a book coming out. It's called A House Needs to Breathe, or Does It? It will be available in the fall of this coming fall, so 2022. Monica Rokicki is founder and CEO of Better Building Works in Roanoke, Virginia, where she helps clients implement cost-effective strategies for high-performance new construction, development projects, and existing building improvements. Welcome, Monica.
Thank you.
John Harrod is owner of Snug Planet, a home performance company based in Ithaca, New York. He is a BPI certified building analyst and Efficiency First board member. He is also a very valued and regular contributor to GBA. Hi, John. Nikki Kruger is Director of Marketing and Business Development for Santa Fe Dehumidifiers. She's been in the indoor air quality industry for over 20 years. She is a ResNet certified home energy rater and a member of the Resource Efficiency and Indoor Environmental Quality Task Group for the 2024 NGBS Standards Update. That's a mouthful. It sounds like really good work. Kramer Silkworth is a licensed engineer providing passive house consulting and mechanical system design. In 2012, he founded Bowcroft Engineering to provide energy efficiency consulting for residential and small scale commercial projects in the New York City and Hudson Valley area, New York. Welcome, Kramer. Thank you all for being here. Try to keep those brief. We could talk about your credentials for a while, but I want to give you due course, but I think without further ado, Allison, why don't you kick things off with presentation that you put together.
All right, well, let me see if I can remember how to do this sharing thing. There's an order. I'm going to try sharing and then switching desktop to slideshow, presenter view. All right, are you seeing the title slide?
Not yet.
Oh, I have to hit the share button now.
Now we are.
You're seeing the title slide?
Yes.
Yay, it worked. Ooh, first time. Yes. Okay, so now, first thing, this title is kind of a lie. It's not really all about indoor air quality because that's impossible in a 1-hour webinar, but we're going to do as much as we can. So let's talk about air. The talking heads talked about air, and they said air can hurt you too, and it's true. But look at this picture, and you don't see the air. And that's why it's so dangerous, because it's invisible. There's so many invisible things that can hurt you. So, and there are different kinds of things, and there's different ways of dealing with the different kinds of things. So let's see if we can sort this out and talk about why it's so dangerous. Let me click there. Okay, there we go. So. We're talking not just about health and the all the different things to keep healthy in our homes. We're talking about the one aspect of health related to air. And that's important mostly because we breathe in lots of air every day. The stuff we breathe in can get, a lot of it gets filtered out in the upper respiratory system and the nose and throat, and doesn't make it all the way to the lungs. But some stuff does make it all the way to the lungs, and we'll talk about which kinds of things make it that far. And the things that can get into the lungs can do the most damage because the lungs are very sensitive. They can put stuff right into the bloodstream, and so we want to keep bad stuff out of our lungs as much as possible. This guy, Philippus Areolus Theophrastus Bombastus von Hohenheim, is also known as Paracelsus. He's the father of toxicology, and has this great quote: "Poison is in everything, and no thing is without poison. The dosage makes it either a poison or a remedy." Brett Singer from LBNL, Lawrence Berkeley National Lab, put this quote in a presentation a few years ago, and I've used it a bunch of times since. I love this quote. The stuff in the air can hurt us, but there's some stuff that at a low enough concentration won't hurt us, like carbon dioxide. Carbon dioxide isn't technically bad for us. I mean, it's not bad for us at a low concentration. We're exposed to it all the time anyway. The atmosphere has about 400 parts per million, 319 parts per million when I was born. Now about 419. And so we're breathing that stuff all the time. But if you're in an environment where you're breathing, say, 2,000 or 3,000 parts per million, or 5,000 parts per million, 10,000 parts per million, then you've got some health effects from that. So, whether it's a poison or a remedy depends on where it is. And of course, it could be neither a remedy nor a poison. It could be in between, just neutral. So let's look at some of the things that we deal with in indoor air. One is particulate matter, the tiny little particles. Sometimes you can see these floating around when the sun is coming in the window, and you see that stream of little floaties in the air. It's really cool. But a lot of them are invisible. And then there's secondhand smoke, which you can see floating around in the air. Nitrogen dioxide, a gas that comes from combustion. Carbon monoxide, also from combustion. Ozone comes from electronic devices and lightning. Volatile organic compounds, off gases from a bunch of different materials that we have in our houses. Mold, which is, there are spores floating around everywhere, and if you've got the spores, if you got right temperature range, if you've got water and you've got food, then you're going to get a mold outbreak, and that's not good because that people can be very sensitive to, and some kinds of mold are really bad. There are allergens of different types, like dust mite carcasses and dust mite poop and all kinds of pollen and things. There's bioeffluents, the things that we emit from our bodies, and radon, another colorless, odorless gas, and viruses that we have all become very aware of in the last 2 years. So this is a list of some of the things that we want to deal with. This is not a complete list, and some of these things are a whole class of compounds, like the volatile organic compounds, the VOCs. That's a whole bunch of different things. Some of them not so bad, some of them bad. So the first thing we want to do in achieving good indoor air quality is source control. Now, you're probably aware that the United States led the world in source control over the last 3 decades or so. You may know what I'm talking about, and if not, this picture will clue you in. When I was growing up, I had really, really bad asthma. Both of my parents smoked, and they smoked in the house, they smoked in the car, and back then they didn't make the connection between my asthma and their smoking. But I was told that I was allergic to feather pillows and Christmas trees, natural Christmas trees. And so I couldn't have feather pillows, and we had the shiny aluminum Christmas tree that the Charlie Brown Christmas special killed, but I loved it. It was great. Anyway, the United States has led the world in source control and getting smoking out of houses. And even in Irish pubs now, there's no smoking. That's amazing. So source control is the first thing you want to do. If there's great quote from a German guy named Max von Pettenkofer. If there's a pile of manure in the house, get rid of the manure. Don't try to ventilate it away. So source control is number one. You want to try to keep the bad stuff out of the air to begin with as much as possible. Filtration is another really, really good strategy. This is a low energy strategy if you do it right. And I've written a lot about filtration. This is the filter in my house, filter grill. We do MERV 13 filtration in my house. Very low pressure drop, has no effect on the airflow. I can go 6 months. In fact, next week, it'll be time to change my filters again. I usually do it in January and July. So I've got, there will be almost no difference in the pressure drop across the filter from when I put it in January to when I take it out next week. But let's go back to that list of likely suspects for indoor air pollutants. Filtration cannot handle all of these. The ones that filtration can handle are these things: the particles, particulate matter, PM 2.5, PM 10. The secondhand smoke from cigarettes, which is all kinds of stuff, mold, allergens, some of the bioeffluents, not CO2, obviously, or methane, but anything that's not a gas can be filtered out, and viruses that are attached to particles. These things can be filtered out with filters. That's what filters do. The standard media filters I'm talking about. There are types of filters that can filter out gases, but for the most part, the things in this list that you can't filter out are the gases: the nitrogen dioxide, carbon monoxide, ozone, VOCs, and the gaseous part of the bioeffluents. So that's what filtration is for. Be very, very clear about that filtration is not going to get rid of the VOCs. The standard filtration is not going to get rid of that kind of stuff. For that kind of stuff, for the gases, typically we want to do ventilation. This brings in outdoor air to dilute the concentration of the gases that we don't want in our air. And, it dilutes the carbon dioxide and VOCs and the other bad stuff in our air, nitrogen dioxide. This is a Zender system. There's all kinds of ventilation systems. The balanced ventilation system is the kind that everybody says is the best because it is the best, balanced with recovery, ideally. Another thing you want to do is make sure that you've got good combustion safety going on in your house. If you've got any combustion appliances, you want to make sure that you're not adding to your indoor air pollutant load with the combustion process. Sometimes that just means ventilation, like the range hood. Whenever you do cooking on a gas stove, you got combustion going on, that range hood should be running. But ventilation doesn't solve all problems. You have to also have good venting of the appliances. As you see here, the flue, in this case, with a trap, will not vent. So when this water heater runs, all the exhaust gases are just going to spill out into that room. Moisture control, very, very important. When things get wet and stay wet and there's food there and you can grow mold, that's not a good thing. This mold that you see here was from rain. This was lots of rain coming into this hall area from a porch over and to the left of it, and it stayed wet long enough that it grew a lot of mold in there. Dehumidification. The overall moisture and water control is one thing. Humidity control is another, and sometimes you need supplemental dehumidification to handle the humidity load, to keep the humidity in the house right. Then there's monitoring. There's all kinds of monitoring. What I have at home is what you see on the top left. I have two of the monitors called the Aware Element right up here. And you can see the 606, that's the CO2 level in my house when I took that photo. This is another one of my monitors, the Aeronet 4. It's a portable battery-powered carbon dioxide monitor, and I take that with me when I travel. This is at the FIAS conference in New York last October. A whole bunch of us brought monitors. This is a different. This is somebody else's Aeronet 4 CO2 monitor. And this is a particulate matter monitor. And I don't remember which levels it's reading. One of those is PM 2.5 and one's probably PM 10. And the resolution is not good enough for me to tell. This is an AirThings monitor. These home monitors give you different outputs. Like the Aware that I have gives you it gives you 6 things. It gives you an overall score based on temperature, relative humidity, carbon dioxide, what they call chemicals, which is basically VOCs, and particulate matter, PM 2.5. So I keep the display on CO2 because that's what I mostly look at. And at least some of the AirThings monitors will give you those things and radon as well. They'll give you a reading for radon. So there's all kinds of monitoring that you can do out there. And let me talk a little bit about air cleaning technology. So we've talked about filtration and ventilation. You can get these in portable all these things in portable air cleaners or different types of air cleaners. So filtration, ventilation, ultraviolet light, electrostatic precipitation, where you have a voltage, air going through a duct system, passing with through a place where there's a voltage, a potential difference, and that potential difference causes charges to separate, and it can collect a lot of stuff from the air passing through. Photocatalytic oxidation, ionization, ozone generators, hydrogen peroxide. These are some other ones. Now, I put these in 2 columns because these are 2 fundamentally different types of air cleaning technology. On the left, we have the subtractive air cleaning technology, which is superior. On the right, we have the additive air cleaning technology, which I advise people to stay away from, because when you put different kinds of radicals and ions and ozone and things into the air to oxidize it or ionize it, and you're adding stuff to the air, and yes, it can take some of the bad stuff out, but it can also create new bad stuff that you didn't have before, because what you're putting something new into the air and relying on these chemical reactions, and you don't know all the chemical reactions that are going to happen because you got a lot of stuff going on there. So in general, it's better to rely on the subtractive air cleaners than the additive air cleaners, in my opinion, and a lot of indoor air quality experts' opinions. So here is a nice air cleaner that you can make for less than $100, MERV 13 air filtration. And in this case, it's 4 MERV 13 filters around the sides with a box fan over the top and a piece of cardboard on the bottom. So it pulls air in and blows it out the top. And let me give you some anecdotal evidence that these things work. So one of my colleagues in my office, Jeffrey, had COVID last November. He did his best to isolate at home. They have not a huge home, so he wasn't able to live in a completely different part of the house. He didn't sleep in the bedroom with his wife. They did watch TV together and eat in the same room together sometimes, but he would always put the MERV 13 portable air cleaner between them and wear a mask when he wasn't eating. And his wife and his son did not get COVID. And another person in our office, Luke, also got COVID and did the same thing, and neither of his wife nor his son got COVID either. So anecdotal evidence, but at least it may have saved a couple of cases of COVID there. So that's my information. I'm on Twitter and LinkedIn. There's an email. I have a book coming out. You can sign up for updates right here at energyvanguard.com/book. And so that's our introduction. Was that?
Thank you, Allison.
Yeah.
That's wonderful. We give panelists an opportunity to respond to any of that or thoughts that were provoked, or start with that, and we can get into some specific questions. But what might you add to that presentation just to get the conversation going? Oh, Monica, you're on mute.
You're muted. Still muted.
So I'll add to what Allison said about the Comparetto or Corsi Rosenthal cube that goes by various names. I recently was in kind of in a cohort with the University of Pittsburgh, and they were doing an indoor air quality study with just various homeowners around Pittsburgh and Roanoke and I think in Maine. And we were painting at the time. And so everyone was saying, well, the cube wouldn't do anything for VOCs, so it shouldn't affect painting. But we had incredibly high particulates during the painting period, and then of course anytime we cooked. But as soon as I turned the Corsi cube on, it removed about 50% of the particulates from the air within about a 30-minute period. And we found out that the dust or the fine particulates that were coming from painting were coming from the drywall repair. So anytime you were sanding that drywall, of course, that released drywall dust or drywall mud dust into the air. So, you know, you'd be surprised how many things we do in our homes that we don't even think are going to produce any kind of indoor air quality issues actually do.
Yeah, in fact, one of the questions that I wanted to ask is, what are some of the lesser known contributors to poor indoor air quality? Like, for instance, moisture from building materials and what that can lead to. To be proactive should be you know, dehumidifying right after dry-in. Yeah.
Well, I'll just say from my experience with understanding humidity is, you know, Allison talked about VOCs and how everything in our homes typically contains some sort of off-gassing. And what we know is the higher the humidity, typically the higher and quicker those products will off-gas. So Chinese drywall is a great example of that. So down in the Florida area, of course, everybody's heard of Chinese drywall. Ken Gehring, who invented our humidifiers, got involved in trying to help find a solution because the drywall was off-gassing and causing formulary corrosion to HVAC equipment, to the coils of refrigerators. And one thing that they identified was dehumidification helps slow the process. Which, you know, when you're in a home and you have children, and that's not a solution that anybody really wants. They really want that drywall out of their house, but they also figured out the drywall made it farther north, but we couldn't find it because the humidity levels didn't stay as high for a long enough period of time to be able to cause the formulary corrosion. So there's a lot of off-gassing from our products in the house just naturally, but usually what they have found, the higher the humidity, the higher the levels and the quicker it happens.
Kylie, since you mentioned it, what I've started doing with all my jobs is after we do the first blower door test is we talk about how you have to be now ventilating this building before you can turn on the ventilation systems, which may not even be fully installed yet, and absolutely have to have, you know, construction stage dehumidification going because there's literally tons of excess moisture in all these new products, concrete especially. And last summer, you know, even here in upstate New York, we had what I think was like a record humid summer. And I had a number of jobs that had just been finishing up construction, could not get their humidity down. So I think it was a combination of the summer and like closing up and moving in sort of all at the wrong time. And maybe that sort of stuff has to stay for the first year, but what used to be a sort of traditional, only mostly Southern thing of having dehumidification in conjunction with AC is absolutely happening up here now too. And I'm basically planning dehumidification for almost all of my jobs going forward now, which is not something, you know, we probably would have seen 10, 15 years ago, but it's between the construction moisture and everything else now, we need dehumidification almost everywhere.
A lot of wet lumber is that's being used in construction right
Yeah, and those buildings are super closed up during construction. I talk to the guys about, opening the windows when they're working and having temporary AC and dehumidification going until the systems can be running.
And like
Somebody-
you were saying with concrete, the speed of construction sometimes, they're framing right after they pour, sometimes days afterwards. And, if you're closing up that building or crawl space or basement super fast, that, that concrete will continue to add a lot of water vapor into the air for, quite a bit for the first 3 months. And then it'll just continue to go down over time. But yeah, we see a lot of issues with that here in our region.
Among the questions that's related to dehumidification is if the chief problem is in most sealed crawl spaces is excess humidity. Is there much sense in doing anything other than dehumidifying? Is there no connection? If there is no connection between the air down there and the house above, do any of the other metrics even matter?
I personally feel that dehumidification is absolutely required in a sealed crawl space, but I don't think that means we can ignore other things like source control. It's really very difficult to completely isolate a crawl space from the living space just because of the number of plumbing and wiring and ductwork penetrations. And so we want to do everything we can to, minimize the number of contaminants, whether it's, fiberglass particles or dust or just about anything. So I would say that dehumidification is important, but source control is also really important in that scenario.
Yeah, I take a combined approach. I have a dehumidifier. If I have a conditioned crawl space, which is preferred, I'll have a dehumidifier and 1 or 2 ERV returns out of that space. So the space is kept somewhat negative pressure relative to the occupied space above. That's sort of a combination of the 2 ways from the code that you're supposed to handle, these so-called unvented or conditioned crawl spaces. So keep the humidity down, but also keep it somewhat negative pressure relative to the living space. Then you shouldn't have much of anything coming up the other way.
I'm going to push back on negative. Why negative as opposed to positive in a crawl?
Negative relative to the living space above by a few Pascal, maybe.
Oh, I understand. Okay.
Pulling 10 or 20 or 30 CFM out. So it's drawing building air, which we're assuming is very well conditioned down and out rather than, anything coming up the other way around.
Understood. Thank you.
Yeah, we did here in Northern Virginia with Habitat, we did a case study on 2 habitat houses right next to each other that we encapsulated them both, and one we used supply air to control the moisture, and the other one we used just dehumidification. And it really showed us from a code standpoint in climate zone 4 that just using supply air when the AC runs to control humidity didn't work. Starting in April through October, it was above 70% in that crawl space. Now, the temperature also was, I think, about 68 degrees to 70 degrees. But it was lifestyle. The people living there like to keep the AC set at 80 degrees. So it didn't run. And so when we have strategies like that, we have to understand we put people in control of a thermostat, and they're going to control what goes into those spaces. So we teamed up with Advanced Energy and Joe Steenbrook and Allison, and we put together a 2-day crawl space encapsulation building science class to understand how air moves and moisture moves. And so it really is focusing on making sure that we don't go into these spaces and potentially making the homes worse by not doing a thorough job of thinking through all the thermodynamics and all that goes into a crawl.
Is that class that you that you just mentioned available for people to see online right now?
It is. We're just getting it a new webpage up. We were teamed up with a gentleman down in Atlanta at a drying academy, a restoration school, and so we're working with them, and then we're also going to be bringing it to our facilities in Madison as well. So as soon as that's back up, if anybody's interested, let me know. But we're looking at a November time frame. Is my voice better? Because I was being told that people couldn't hear me. So
It's a little tinny and broken up, but we can make it out.
okay, I'll try a little bit.
Oh, that's better.
Here.
Whatever you
Is
just
that
did
better?
is better.
Okay.
Yeah, that's better.
I'll do a little Roger that.
That kind of reminded me of a question that somebody was asking about, occupant, it sort of gets at occupant behavior and outside of the GBA community of building science enthusiasts who can probably be trusted to maintain an HVAC and ventilation, an HVAC system. Do you think it's a good idea to involve occupants in these areas through data collection and user input in the controls, or is a set and forget kind of a system better in terms of ensuring good indoor air quality in residential settings? Allison or Kramer?
At the very least, the occupants have to know what these systems are and their basic function, and change your filters.
Mm-hmm.
I undoubtedly get a call about 6 or 8 months after someone has moved into the house and said, "Oh, it's great. It was great at first. Now it feels kind of stuffy in here." It's like, well, when was the last time you changed any of the filters? It's like, what filters? Okay, problem solved. Whether homeowners get into that themselves or hire a service company to come and do it, but somebody has to be maintaining these systems.
Now, based on what Kramer just said, I think I have an idea what the question was, but could you repeat it, Kylie?
Question, sure. Outside, let's see. Essentially, do you think it's a good idea to involve occupants in collecting data and getting into the user controls, or is it's sort of like the set and forget system better? Yeah.
So adding to what Kramer just said there, definitely, filters and knowing where the system is, and also knowing if it's running or not. If a heating or cooling system doesn't work, they will know because the house gets too cold or too hot. If a ventilation system stops working, they can go years without knowing that it's not working. And this happens all the time. So either have homeowners that will monitor that, a couple times a year, make sure it's working, and or even better, have a company that will come in and monitor it for them, or service it for them, maybe once a year, twice a year, check the filters. And actually, filters need to be changed more than twice a year on ventilation systems. They get the filters on the outdoor air get black very quickly, and depends on where you live, of course. And especially if you're anywhere where wildfires are happening, you're going to have to change filters all the time.
Mm-hmm. And like definitely don't, I think Kramer alluded to it earlier, running those systems during construction will, you can even kill them. You can kill the system before you ever occupy the building. But in any case, make sure that the media is new when you occupy the building. And even for new buildings, run the system pretty much full out is what I recommend people in new homes, because of course we're putting all kinds of new stuff in a new home. So that could be, a source of high VOCs, urea, formaldehyde, all kinds of things. And if we can flush that building out for the first 2 weeks, 3 weeks, and then turn that ventilation back to where it needs to be per blower door test and a correct ASHRAE 62 calculation, then we can, start with a good baseline when we're occupying a building.
Speaking of baselines, one of the questions is, do you think that CO2 levels are really a good proxy for indoor air quality? Consider a house that is unoccupied all day. Carbon dioxide would be low, but other contaminants like VOCs might be building up. Anybody speak to that?
I guess I would say that carbon dioxide is an important component of indoor air quality, but it's not a good overall metric for your total air quality. It tells you a lot about occupancy, the number of people and their density relative to the amount of air changes you get. And it's also been used kind of as a proxy for other bioeffluents, whether it's just, body odors or viruses given off like COVID. It represents, kind of a measure of the occupancy driven contributions to poor indoor air quality. But there are other things like VOCs, like particulates from outdoor air that aren't reflected at all when you measure CO2.
Yeah. Let me say one other thing.
Yeah.
Going back to what I said in my opening presentation, CO2 is a gas. And if you've got an occupied space, yeah, I mean, as you mentioned, if the space is unoccupied, CO2 levels can be high while the other gases, CO2 levels can be low while the other gases, VOCs and things, can be high. But if you've got an occupied space and you have a ventilation system, and you've got people in there, and the CO2 level is going too high, that means you're not ventilating enough. So it gives you an idea about the ventilation rate. It doesn't tell you whether your VOCs are high and other things. Monitoring can help with that. It also tells you nothing about the particulates in the space, because the CO2 gives you an idea of your ventilation rate, and that can help with particulates, or it could make particulates worse if your filtration on the ventilation is not good.
Yeah, I like a combination of CO2 and particulates. I do find sometimes that, us building sciencey types, I mean, we love, all of the data, and we have enough experience and also understand a lot of times what we don't know when we're looking at data. What does it really mean? We're always interrogating the data. Whereas I find a lot of homeowners get kind of frustrated and confused by too much data. So it's an open question in my mind, what should we really be monitoring? Just because we can monitor more stuff, is it really giving us more actionable knowledge and information? And so I've kind of come down, to where CO for sure. If you've got combustion equipment, you need a carbon monoxide monitor, no question, just do it. And it needs to say what the low levels are.
Yes.
Not just run out of the building screaming because, now you've got a real problem. But CO2 and PM 2.5 are kind of my right now favorite things to monitor. And I think people can, when they see them go up, they realize, oh, they go up all the time when I'm cooking, or they're up because outdoor, levels are high. So, look at those as well. And then, like you said, Allison, I think CO2, while it's not perfect for VOCs, a lot of the VOC monitors out there are measuring all kinds of different things. We don't know what their actual proxy is because that can be proprietary information. And those sensors, I just don't have enough information about them to know what they're really saying. And they're not going to say what exact VOC it is either, which a lot of people want to know, but you can't really tell them. So,
speaking of VOCs, the thing that drives my aware element IAQ monitor the highest on the chemicals count is when I open a bottle of whiskey. It'll go up to 4,000 or higher sometimes, parts per billion.
Goodness.
So it's not always a bad thing when the VOC number goes up.
Does it matter if it's a good bottle or a bad bottle? I mean, does it tell you that?
I don't have any bad bottles in my house.
Oh, okay.
Well, I would buyer beware on some of the Wi-Fi enabled devices that you have out there, because we were doing some, pretty in-depth monitoring for people. And, it's amazing what you can learn about people from air monitoring, and people who, cannot necessarily be trusted with the data, what they might want to sell you as a result of it. So.
I feel like I should get to a couple of audience questions, one of which is, we always talk about balanced ventilation in an effort to keep the nasties out of the building. What are the thoughts on running slightly positive pressure, example 1 or 2 pascals?
I really like the idea of running the house at a slightly positive pressure. There was, in times past, there was a lot of concern in northern climates that a positive pressure would force moisture into walls and other interstitial spaces. It turns out that really appears to have been overblown. When you positively pressurize the house, you reduce the amount of infiltration from spaces with poor air quality, garages, crawl spaces, wall cavities, and so on. And you also have much more control over where your ventilation air comes in. You can pull it all through your ventilation system, filter it with a MERV 13 filter before it even comes into the house. So I guess for all those reasons, plus the additional benefit of reducing drafts, I would say overall, I'm coming around to the idea that the slight positive pressure is a good thing.
I would
Yep.
agree. Mixed humid and humid climates for sure. Unfortunately, I've worked on a lot of projects, especially multifamily and townhouses in climate zone 4 here in the Mid-Atlantic. And, everybody's using exhaust only ventilation, and then they wonder why they're having moisture issues. So if we could hopefully get away from certain climate zones, especially humid ones, using exhaust only, that would be great. We need direction. Just because it's cheap up front doesn't mean it's going to be cheap in the long run.
Yep. And running with a slight positive pressure doesn't mean you can't use an ERV, because you can run an ERV with an unbalanced pressure. You can run a little bit higher on the incoming air than the exhaust air.
I have a HRV, ERV related question. It's a bit of a scenario, so hang in here while I read it to you. Integrating an HRV or ERV with a heating and cooling air system makes good sense to reduce ductwork and associated cost and space. But if it requires running a 350 plus CFM air handler unit on low speed to pressurize the system for 100 CFM of ventilation air continuously, that's a lot of watts 24/7 and potentially noise depending on the acoustic quality. How do we optimize system integration? I ask this because it comes up on GBALS. How do we optimize system integration to have one set of ductwork connected to 2 different systems on different controls at different flow rates, operating at different but overlapping times and cycles? That's a big puzzle, but I'm wondering if you can talk about the integration of systems, just because people seem to want to do that.
I'll just make a couple points that relate to this. One is that by connecting your ventilation system to your central air handler and then running that air handler continuously, you accomplish a couple other things besides distributing that ventilation air. One is that you are now cycling the air in the house through your central filter, so you have the better ability to remove particles. And the other is that you're mixing the air in the house. And it turns out that mixing the air in the house is a much more energy efficient way to dilute locally high concentrations of carbon dioxide, like you might get building up in a bedroom with a closed door. So running that central air handler has benefits besides just distributing the ventilation air. And if you do it with a ECM motor on low speed, the watt draw is going to be quite reasonable.
Yeah, this has sort of been the holy grail of residential HVAC design for a while, and in the passive house community especially, because traditionally, for the 10 years, that means we've had 2 totally separate systems, mini splits and ERVs. And if they're ducted mini splits, that means 2 sets of duct, 2 duct systems, 2 sets of grills that don't look the same, all sorts of stuff. But a lot of it can come down to like the floor plan of the house too. Is this a single zone system served by a traditional furnace or central air system in the basement where you're mixing, all the supply air from one system around the whole house, or like what we're seeing in a lot of high performance homes now is, there's 2, 3, 4 or more different mini split zones around the house. It may be a mix of ducted and ductless. How do we then take air from what might be one central ERV and bring that to all these different zones? And it can be done, but it's tricky. The controls don't speak the same language. They're not meant to be tied together. We have interoperability issues there. Balancing has been a problem until recently with some of the self-balancing ERVs that have come on the market. So we're getting there, but there's still kind of a lot to figure out, and it's still very much a kind of case-by-case basis with the house and what its heating and cooling systems and zones are, because heating and cooling is a totally different thing from ventilation, but we seem to want to cram them all into one box all the time, because that's, for many reasons, but they're two totally different purposes. So it's hard to get them to all work in the same distribution systems, same control systems.
Let me take the other side of this and put in a plug for independent ducts for ERVs or ventilation systems, because if you, ideally you want the ventilation air to be distributed to the bedrooms, because if people go in the bedrooms, they close the door at night, you want that ventilation air to go into there so that, the CO2 level doesn't go up to 2000 while they're sleeping in the bedroom. Could you try again? What? Shut up, Siri. So independent ducting is I think the ideal way to do it, but you run into the issue of space. Not every house has the space for 2 or 3 separate duct systems. I mean, if you got heating and cooling ducts, and then you've got your ventilation ducts, and then you've got a whole house dehumidifier, that's a lot of ducts going into the house. And then maybe you're ducting your heat pump water heater,
your range hood, your makeup air, and your dryer, and
so the space is an issue, and so sometimes you do have to tie these things together. And in our design practice, we do combine ERV ducts with air handlers sometimes. David Trelevin wrote a really good article in GBA several years ago about ducting ERVs and dehumidifiers with air handlers. I'll find the link and post that in the chat in just a second.
I think that's probably one of the #1 articles that I shared.
Yeah, me too.
Everybody asks. Yeah.
Okay. That's good to know.
And it's kind of one of those things, everybody wants to do it, but then when they realize the pros and cons, because it's a really great article on the pros and cons of all the different ways to do it.
Yep.
But it's really informative.
A couple of air intake questions. I'll combine the two. One of them is from an audience member. They are asking, would the location of your air or your intake air make a difference for the lifespan of a filter? And the other question is, what are the best locations for supply air intakes? I feel like
I had a client who had an issue with odors that we finally figured out what it was, but it was this mystery odor, and it smelled kind of chemically, and it turned out that it was a set of chemical reactions that had started by a company bringing in some moldicide, magical moldicide, and then not solving the cause of the issue, which still brought in a bunch of water vapor. And then they came in and did a bunch of ozone generation and basically created this monster of a chemical reaction in their house. So of course, the solution to pollution was dilution in this case. And we thought we were locating this, exhaust in an area where it would not get pulled back in the house. But because pressure, there's pressure, things happening, every time they opened a certain window, all of that exhaust would come back into the house through that window. And similarly, exhaust gases can be brought back in through like a supply vent. So we also see sometimes radon venting, very near to, because that's done kind of after the fact, after maybe they did locate the supply and the exhaust 10 feet away, and ideally on 2 sides of the building, then suddenly you've got an exhaust from radon that's just getting recycled back into the house. So you really got to think about not just how far these things are away from each other, but what kinds of interactions with prevailing winds and pressures could be happening that could potentially bring exhaust back right in through the supply. And then, of course, supplies shouldn't be too near the ground, because ground is where water vapor is going to be the highest.
What about the filter piece of that question?
One of the things that I see a lot when I'm cleaning ERV or HRV filters is that they tend to accumulate quite a few insects, as well as other things like dandelion fluff and stuff like that. So I think ideally you want to, it's one more reason to try and get it high off the ground, but not in a location where you're going to be getting some of the VOCs that might come off of hot roofing materials.
Mm.
Yeah. Also, if you live in a place where there's a lot of bad stuff that would make you change the filter a lot, let's say wildfires is one example. Love bugs in Florida, maybe, if you know what those are.
Mhm.
You could have a pre-filter, and you could filter out a lot of that bigger stuff with a much less expensive filter, and then have your MERV 13 filter downstream from that and not have to change it as often.
Would that require different ducting, Allison?
It might, but I mean, you can use like a MERV 2 pre-filter, and that'll catch a lot of the bugs and stuff, assuming you don't have bypass around it.
Oh, wow.
Yeah.
Switching gears a little bit, John, you did a really great piece for this whole expert exchange quarter about climate change and the role it will play in indoor air quality and what we do to handle it. I wonder if you could speak on that a little bit in the form of, do you foresee ASHRAE 6.2 and building codes for ventilation rates changing in response to more extreme weather conditions? And do you think that the existing guidelines are sufficient for good indoor air quality?
So, there's a couple trends that we're going to see related to indoor air quality related to climate change. One is that we're likely to see higher levels of particulates coming from outdoors. And that includes things like, wildfire smoke and all the soot and the PM 2.5 that brings in, but also pollen levels are going to be, the pollen season is going to be extended, and plants are going to be producing more pollen in response to higher CO2 levels. So I think we're going to need to think more carefully about doing good filtration on the ventilation air that we bring in. We are also, I don't know yet how that is going to impact recommendations for, volume of filtration or volume of air that we bring in. But I do think we need to think a lot about how we filter the incoming air.
Any other thoughts on that topic? It's a big one,
I
especially
think
given today's news.
I think we need to be prepared for, I think we're designing for past history, and codes are always based on, decades and decades in the past where we see accelerating change. And while that accelerating change seems to be very small increments, the extremes are much wider than these small kind of average increments that go up. And so I used to work for one of the premier scientists at the forefront of climate change research in like the 80s and 90s. And what he used to say is, Dr. Joseph Goldman, he used to say, extremes are going to get more extreme and less predictable. Dry places are going to get drier and wet places are going to get wetter. And so when we're designing for, and everything is going to trend warmer, of course, but that doesn't mean we can ignore, for example, in Southwest Virginia, the potential for very cold days, although there will be fewer of them, and also for sustained periods of humidity, and not just rely on the past. And I think this is extremely critical for areas where most of the population really lives, which is near water, bodies of water, where you're getting water rising. And of course, the humidity associated with that is an issue as well.
Kramer, you said that there's a topic that you've been talking about a lot lately that feeds into this to some extent in terms of planning and the problem of oversized HVAC systems or equipment rather, and how you need to be getting into that earlier in the design phase. You see a lot of problems going forward if that doesn't change. Maybe tie in to this whole idea of like, we really need to be changing. But there are some obstacles as you're talking about, so.
Yeah, I mean, it's something that, you know, I do residential HVAC design, and that's, you know, whether it's passive house or high performance building or even just barely code compliant now, with all the systems that we have, you know, heat pumps, whether they're ductless or ducted, ERVs are great in high performance buildings, range hoods that are oversized, and then we need to deal with makeup air for them. And even though code says, you know, we need makeup at 400 CFM, there are plenty of situations in smaller or tighter houses where a 250 CFM hood might need a makeup air system. You know, and people are still doing, you know, wood stoves and fireplaces in these houses. So you have to be very careful with building pressure there. You know, heat pump water heaters that either circulate indoor air and make a bit of noise and are great as dehumidification, but only if they're working with the air. There's all these systems in buildings now that are now, you know, scattered throughout the house. It's not a boiler and a water tank in a mechanical room in the basement anymore. It's stuff that's kind of all over the house. There's ductwork running everywhere, and we need to be planning earlier for that. You know, where all that stuff can go and how big is the ductwork going to be? What is maintenance and access requirements like? I see so many people come to me with a set of plans. Oh, we just got our permit. We're breaking ground next month. Can you design an HVAC system for us? It's like, you're 6 to 9 months too late to start thinking about integrating a decent HVAC system. And, you know, some folks are thinking, oh, we'll just put a mini split head in every room. Well, that's going to be seriously oversized and not dehumidify well, because we don't have small enough ductless mini splits yet. So great. So we'll combine a few rooms and put them on a ducted system. Okay, well, where's the unit going to go? Where's the ductwork going to go? How's the return air going to work? What's transfer air going to be like? We can do a rough layout pretty early on with, you know, schematic design level floor plans, but we have to be thinking, where is this equipment going to go? How are we going to service it? Please get it to be the right size. Do a load calculation. There is some stuff out there that is so obscenely, grossly oversized that it's just insane. These systems are going to cycle themselves to death in a few years because they're so oversized. And you still have HVAC installers saying, oh, well, these things will ramp down to 1%. It's like, no, that's absolutely not true. Some of them go at best 50%. And you know, the sizing is not an issue. It's not being enforced. It's becoming a big issue, I think. I try to do the tightest load calculation I can, but I know it's, you know, when someone moves into their house and it's kind of been hot and they can't cool it down within an hour, that's a whole other world of like philosophy that we've got to deal with, and like managing client expectations with what we're used to as oversized AC systems. So point is, kind of on my soapbox here, but we have to be planning about HVACs, you know, so much earlier than we are. Everyone's gotten very excited about, you know, thermal bridge detailing and air sealing and everything else, but HVAC has, the can has been kicked down the road still, and it's not until it's too late. You know, it's not until the house is too hot, too cold, too damp, poor indoor air quality, whatever, that people care about this stuff. Because when everything is working right, no one knows anything is working right. There's just, we're comfortable, it's well ventilated, but when things go wrong, it's a lot harder to go back and fix after the fact.
Absolutely. I
Rant over.
No, that, and I earlier in May at the Humid Climate Conference down in Austin, Brian Orr if any of you ever heard of Brian. And Kimberly Llewellyn from Mitsubishi did a presentation. Basically, what you're talking about, Kramer, is, you know, the HVAC guy gets blamed for all these things afterwards, but he's also the last to the table.
Yeah.
And you don't bring them in when you should, but then when things don't go perfect, you blame them for everything.
Right.
And so it's really about, you know, and it was really a room of a lot of architects and engineers and builders. It's a message they need to hear. Get everybody involved and get them at the table much sooner, so everybody understands the goals of the home and the build and what's going on, and everybody can work together to achieve it.
And it is so important to get it right to begin with, because whatever you end up putting in a system to begin in a home to begin with is probably going to be there or be replaced in kind almost exactly as it was throughout the life of the building. So it's you know, the decision making time is then, and you know, like you said, Kramer, it's way more complicated after the fact, and it's much more complicated for existing buildings. And you know, I see very few, if any, HVAC contractors that are doing load calculations for buildings that are, you know, getting tightened up. Maybe they're, you know, 20, 30, 40, 80 years old, whatever. You know, once you tighten that building up, you might have an already oversized system, now even more oversized, because an HVAC contractor is just going to come and boom, 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 you know, just put in exactly what was there to begin with.
No, you put in an extra half ton just in case.
Of course. It'll work
Well,
even better.
it could very well be, my colleague Andrew today said earlier in response to the EPA, you know, not having as much jurisdiction over the polluting of fossil fuel plant emissions, that indoor air quality is going to be even more important as we move forward. So potentially the silver lining here could be that people start paying attention to HVAC systems and sizing earlier in new construction. Yeah.
And give us big mechanical rooms.
Right. Yeah, right.
Distributed mechanical rooms.
Yeah.
With access to outdoor air.
Yes.
Yeah, designing mechanical rooms. That's a good topic to accommodate all these things, because yeah, as the point was made, they're just it's getting more and more complicated and takes up more and more space, and the simpler probably the better, but there's so many factors and variables, and that's true of this topic. As Allison pointed out at the start, we can't cover it all, and we could go in so many different directions, and hopefully people will have gained something new here tonight. And thank you all very much for attending. We are at the hour. Maybe some parting thoughts. Anybody have something that they didn't share that they'd like to share? No pressure, but.
No, I would just say, think of a house as a system of systems. And if it's an existing building, there is no such thing as an average approach. You have to look at it as a customized solution.
I appreciate you saying that, Monica. I liked your piece that you contributed around, you know, existing buildings are so unique and challenging, but there are things that people can do. And you did a nice job of covering those low-hanging fruits, which I didn't choose to stress here tonight because I think our audience is beyond that. But for the average homeowner, those are really good things to know, practical. So thank you for that contribution. All right. Well, thank you all very much. It's nice to see you. Appreciate the information.
Yay.
I'm calling it a night.
Thank you.
All right.
Thanks.
Great
care.
to be here.
We'll see you soon.